Myself, Dinesh Kumar. I'm doing masters in cloud computing. So yeah, so I'm in a second semester. So as a part of my second semester, I'm submitting my research proposal. My research concept is on for computing subject in the area of resource management. So as coming to the part of my research and proposal, I'm doing a load balancing algorithm, energy-based load balancing algorithm, in which the load of the fog nodes, assigning the task for the fog nodes based on the energy level. So let's coming into the part of the why we are moving into the fog computing, uh, why we are not using the cloud computing even this is developed, because as we are technology is developing, internet of things is becoming a booming in the world. So as internet of things usage is increased, as we have the cloud computing, which is capable of doing, which has a capable of doing computational power, storage and everything, but it is placed far away from the user. So based on that, we are having issues called latency, overloaded, and higher energy consumption and delays. So based on that, the request, the task which has to be performed immediately, which has to be required immediate response, it is taking so long time uh, to complete the task. So that's why the Cisco is invented for computing. So as for computing came into the world, a for computing is placed in between. This is the architecture of the for computing. How it is placed. It is the main cloud is it is the main data center, and these things of tire is called Internet of Things, which we use daily, which are like smart vehicles, smart homes, everything. And the fog is placed in between the cloud and Internet of Things. Fog is nothing but a small data centers which used to have the capability of performing computational power, computation and storage, and which are placed near to the user. So it gives the response faster than the cloud computing. So then that's the reason latency is decreased as fog computing is came into the existing. But even the fog computing having the low latency, but energy, or it is consuming higher energy, and this has to be optimized, and the load on the fog data centers has to be equally distributed in order to get to be overloaded or underloaded. So that's the reason many researchers have worked on load balancing algorithms and everything. These are the fog computing challenges mostly the researchers worked on. They are like energy optimization, load balancing, and the quality, and based on this providing a good quality of service, that is called improving quality of service by using SLAs. So as I design as my concept is about to designing an active-based load balancing algorithm. Before that, many researchers have happened. This is like one of the research called active load balancing algorithm, which that means on the fog nodes the task can be assigned based on the low latency. It's just like if the fog node is which is near to the user request, if it is available to produce with a low latency, then the task is assigned to that. But here the energy of the fog node is not taken into the consideration, also the load. And if you take dynamic, and next algorithm is dynamic energy efficient resource allocation. This in this there's the resource the fog the task can be assigned to the fog nodes based on in the ascending order. That means which takes the minimum energy to complete the task. So one more algorithm is called min-min scheduling algorithm, in which the task which takes minimum execution of time rather than the energy on the load, the task can be assigned to the fog node, in which they are not considering the load of the fog node and also the energy of the fog node. In this energy aware load cloud fog offloading algorithm, in this energy in which this algorithm is mostly designed for the smart industries like manufacturing industries, which were robots working in industries. But here also they are facing they are not considering the load on the fog nodes. So every algorithm has some pros and cons, even they are compatible with some situations. So right now, many like if you want to implement the fog computing in the real world, it takes a lot of expenditure, and also in order to be implement the in the real world, we need to conduct a few few test cases, whether it is adaptable or how it's working and performance and everything. So based on the many simulators are there like Fogburst, Cloud Sim and everything. I'm using a iFog Sim simulator. Why basically iFog simulator is like iFog Sim mostly use it for the resource management, load balancing algorithms. As my research is went on few simulators, but this is the best suited for a load balancing because in which we can customize the algorithms. So in that it is an extended version of the Cloud Sim. So from the Cloud Sim, it has to few fundamental fundamental classes. It's like we can develop this algorithm on the Java programming language in which the fog devices, sensors, actuators, tuple applications. These are the main things in the iFog simulator class. So my proposed algorithm is the energy-based load balancing algorithm in which I will tell you the working operation. This is my workflow algorithm. When the requests are collected from the IoT devices, it will check the fog node which has the energy it will check the fog nodes which are connected, then the energy level of the fog node it will be checked. If it is energy level meets, then it will go for the load on that fog node. If the load on the fog node is heavy overloaded, if not perform the task, then it will go for the again back step and it will check the fog nodes connected and it will check the energy level and it will assign the task. If the load is not overloaded, it assigns us as complete the task. If otherwise, if energy level not doesn't meet the requirement of the fog node, then the fog node is connected to the energy source and the task is directly sent to the cloud without wasting of time. And the task is completed and the request will be sent back to the user. So this is the proposed algorithm. This is the algorithm which I've written here. I will give mention first like energy of the fog node, and then it will check if the allocated device is equal to null, then it will go for the fog node, and then it will go for then it will check the load level of the fog node. Then if the then allocate the devices, otherwise it will go for the energy level. Again, it will check and it will do the process, and repeatedly the fog nodes uh, repeatedly the fog nodes energy level is updated. This is my proposed concept. Thank you.